finally, one that's a little different. The degrees are the same. We take the ratio of the coefficients. It's -1/1, which is -1. Y equals -1 is the horizontal asymptote. Now, here there are factors that reduce out. Okay. So the one that's left gives us the vertical asymptote. Set that to 0, x equals -1. Vertical asymptote at x equals -1. Now, the one that reduced out is going to give us the whole. So 1 is 1x minus 1 is 0, comma. If I plug this in to the remaining reduced fraction, I get -1/2, don't I? If I plug in 1. And so when I plug in 1, the y value is -1/2. And so we'll put a circle at 1, comma, -1/2. In looking for the intercepts, you work with the reduced fraction. Otherwise, you'll use the whole for other things that it doesn't really work. So when the numerator is 0, the fraction is 0. So I plug in 0, and x is 0, y is 0. And as it turns out, the x-intercept and y-intercept, again, are the same, 0, 0. That's not always the case, but for the last 3 examples, you're right, it was. So the vertical asymptote is at -1. The x-intercept is at 0. Those are your boundaries for your regions. I would plug in like -2. Now if you plug in -1/2, that might make you worry, but don't worry, it's not hard. And to the right of 0, how about 1? Let's just test this one. If I plug in -1/2 for negative of -1/2, it becomes positive. If I plug in -1/2 plus 1, that's positive. A positive over a positive is a positive. So between -1 and 0, it's positive. Well, it's got to go through my intercept, and it's got to be positive between 0 and -1. To the right of 0, we see that it's going to be negative, so below the x-axis, but don't cross the asymptote, and make sure you leave a hole where the hole is. Show that hole as being definitely on the graph, but not included. And then to the left, I plugged in -2, I get a negative. That's just like before. I go towards these 2 asymptotes, but stay below the horizontal asymptote and to the left of the vertical asymptote. Okay, so for D, it's bottom heavy, so the horizontal asymptote is 0, the x-axis. Okay. I can factor the denominator. Nothing reduces out. So the vertical asymptotes when the denominator is 0 is x equals -2 and x equals 1. Since the numerator is never going to be 0, we don't have any x-intercepts. When I plug in 0 for x to find the y-intercepts, I get 2 over -2, which is -1, so the y-intercept is 0, -1. I just had vertical asymptotes. I didn't have an x-intercept, so there's no boundary for x-intercepts, only the vertical asymptotes. And I tested the regions. I would plug in -3. How about 0? Nice easy number to plug in. And to the right, 2 or 3, doesn't matter. Pick a number to the right of 1. If you choose 1,000,000, that's fine. Check for yourself to see if you can figure out that this is positive, this is negative, this is positive. Positive stays above the x-axis and goes towards both asymptotes. Negative from the intercept, it's got to go through the intercept, and it's got to go down towards the asymptotes, can't go up. And then positive between these two asymptotes, and you can't touch this. Last but not least, we have E here. Everything factors, and you might anticipate something reducing out, but it doesn't. Nothing reduces out. So then we see that it's bottom heavy, so the horizontal asymptote is y equals 0 because if it's bottom heavy, the bottom's going to grow faster than the top, and a bottom heavy fraction gets closer and closer to 0. The denominator is 0 when x is negative 3 and when x is 2. Those are our vertical asymptotes. To find the x-intercept, we set the function equal to 0, which just means the top is 0, and that's negative 2 when y is 0. So negative 2, 0, here is our x-intercept. Plugging in 0 for all the x's and working it out, do you get negative 1/3? That's good practice for you. So over here we have the y-intercept when x is 0. Now again, our boundaries for our regions are the vertical asymptotes, negative 2, 3, and 2, and the x-intercept of negative 2. We don't worry about the y-intercept. I would pick negative 4 to the left of negative 3. How about negative 2.5 between negative 2 and negative 3? How about 0 between negative 2 and 2? And how about 4 to the right of 2? Go ahead and practice plugging these numbers in, and just worry about if the answer is positive or negative. We don't care about the number itself. And so here, if I plug in negative 4, the top is negative, the bottom is positive, that's negative. If I plug in negative 2.5, if I just add 2, it's still going to stay negative. And in the bottom, negative 2.5 will make this positive, make this negative. A positive times a negative is a negative, and that's positive. Go ahead and do the other two on your own for practice and show that these are the actual signs for the regions. Please note, we don't worry about the y-intercept. So to the left of negative 3, it's below the x-axis and goes towards these two asymptotes. Now watch this. From negative 3 down, it's got to go towards the x-intercept, right? And once it hits the x-intercept, to the right of it, that region's negative. And sure enough, all of it to the right of negative 2 is negative. And then to the right of 2 is positive, goes towards the asymptotes. I hope you're getting used to that.